So my name is David Borel, and we'll be doing a talk today about the Avatar SDK. This is a new SDK for Unity from Oculus, and it allows you to visualize your hands and your users' avatars in VR. So just to let you know, I'm not actually on the Avatar SDK team. I'm covering for Mike Howard, whose wife is going into labor right now. But I'm pretty familiar with the SDK, and hopefully I can direct your questions, if you have any, to the right resources. So about the Avatar SDK, it's a new SDK, as I mentioned, for visualizing your hands and player representation. This is something that's configured by the user. If you're familiar with like the Wii Miis or the Xbox 360 avatars, you might get the idea of what an avatar is, but the focus is a little bit different here. We'll be shipping this at the same time as Touch, and the implications for avatars are a little bit different in VR, so I'll go over some of the differences there. It's supposed to be, absolutely trivial to integrate into your app, so I'll kind of walk you through the steps, but I think a lot of what we talk about here will just be kind of what the Avatar SDK is and why it's useful. And by the end of the talk, you should be able to, integrate the Avatar SDK in about a month when it launches. So this is what the avatars look like, and they're highly configurable, but they do tend to be abstract. We're only tracking your hands and your head, and so using that data, we're able to, and also the audio input from the microphone. Using only that data, we're able to kind of meaningfully animate these. So we unveiled these at OC3. Anybody here at OC3? OK, a few. Yeah, so that's where Brendan introduced them in his keynote. And we also announced a Gear VR app that will be using not a direct application of the Avatar SDK, but similarly styled avatars called Oculus Rooms, which will be shipping on Gear VR in the near future. But the point of avatars is to give the user a consistent identity and kind of representation across all of the apps that choose to use the SDK. We'll be launching them along with Touch, which is shipping in December. But you can get I believe the 1.11 SDK will include them, possibly 1.12. But stand by, they'll be out in the next few weeks for you to use. So this is kind of how they look in the app. As you saw, they were moving around, and the head follows tracking. So a little bit about why they look that way and kind of how we got to this approach to avatars. Has anyone here used the Toy Box demo? OK, a few. Yeah, you kind of have to come to our HQ to try it. There are a few other installations, but it's a one-off app we made back when we were prototyping Touch. And it focused on low latency VoIP and tracking over a network, so that you could have two players with Rifts and Touch in two separate rooms or across the world, and they would have kind of this sense of being in the same place together, and we call that social presence. But in developing that app, we had to significantly modify engine-level physics and networking and audio streaming code to get that social presence that we were looking for, and so. As we were developing additional apps for Touch launch, we found that they were either having to replicate a lot of that work, or they weren't hitting the same quality bar that we strove to hit. So we made an SDK internally that was kind of only shared with internal devs, and it turned out to be something that was very popular, and we definitely wanted to ship this along with Touch so that people can avoid a lot of the pitfalls we ran into. So to define some terms, hand presence first is in VR, when you look down at your touch controllers or whatever VR controllers you're using, you see the articulated controllers. Hand presence is when you feel like those are not controllers, but actually your hands. Leap motion is one good tracking device that kind of strives for some of the same quality levels, but the difference is, instead of feeling like you're manipulating something, you actually feel like you're there, present in the experience. We've talked a lot in the past about the sense of presence in terms of rendering and head tracking and latency. There's also perceptual psychology that kind of affects whether you have proprioception. There's a lot of literature around, people's sense of immersion as a result of factors like, responsiveness to head tracking and also the sense of hand viability. So that's what we're trying to achieve with, with this SDK. We're also trying to make it feel like two people using VR in totally disparate locations can actually feel like they're occupying the same space. So we call that social presence. And again, social presence is to look at another person in VR and not think that they're a representation of that person, but that there are cues that actually come from the person and that you're in some sense actually in the same place. So there's kind of a subtle distinction there. But if you don't achieve social presence, if you don't achieve hand presence, you can run into a place called what we call the uncanny valley, which is where you have avatars that are almost plausible but not quite, and the fact that they're almost plausible makes you start judging them more closely, and then when they fail your tests, such as correct skin movement, high fidelity motion, you don't want a lot of interpolation, then it really starts to smack of kind of a wax doll or something. So that was a major goal for this SDK, was to avoid that sensation and really just give you the meaningful high signal data that we had. So again, for prototyping, we were developing all this in the early days, over a year ago now, in Toybox, and we invested a lot of time and energy in developing this quality of social presence and hand presence. And immediately, there were a number of apps, in Unity and other engines that wanted to use this kind of SDK, and it wasn't available yet. So we were kind of, refactoring what was there in Toybox and sharing it. And that wasn't very maintainable, and also the appearances of the avatars were kind of limited. There was only kind of a Blue Man Group head there. So what we've done is encapsulate this stuff in a way that you can customize, the player can customize it, and then they actually get what they configured across all of their apps. So it's important to us not to have incorrect or faked data in the avatar's motion or appearance. It's just what the user set and kind of the tracking data that they're getting from the VR system. They can configure things like the outfit they're wearing, their hairstyle, the glasses, and the general face shape. Currently, the mouths do not move, but they do, they don't form like actual words, but they move to indicate who's speaking in the multiplayer app. Again, because we would have to interpolate a lot of data there, and it would start to smack of simulation and not the person's actual movement. We've also built a number of ways for people to customize the appearance, and we have an avatar editor that'll be launching inside of Home for people to do that. So on the left here, you see, you see a person configuring their glasses and the outfit they're wearing. There's over 1 billion different combinations, so there's quite a big space for you to configure. It's also important to mention that when people are using their avatar, they immediately have a sense of familiarity with a new app. They jump in, they look down, they see their hands, and they know that you can reach out and grab things, that a certain mechanic is there. It does help to kind of unify experiences and make them more continuous. And that's kind of important because one thing we strive for at Oculus is kind of a seamless ability to jump from home in VR into an app in VR and back to home, and kind of never have this sense that you are kind of like switching windows or processes and kind of look at it holistically instead of having the traditional isolated experiences of app life cycles. So that's a brief overview of the avatars themselves. And now let's talk about the SDK. Our goal here is to provide people, again, with a way to consistently and comfortably represent themselves across experiences. At its heart, the Avatar SDK provides a renderable representation of a person's avatar, taking their Oculus ID, if you're familiar with our platform SDK, and then fetching the customized appearance that they've made for themselves. That includes some meshes, some materials, skeletons and poses implemented using Mechanim, animated to match the movement of the tracked headset and controllers. We also provide information about the current hand configuration. So as the user is grabbing the controller, if you're familiar with touch, there's actually capacitive proximity sensors on each of the buttons, and you can tell how far away the index finger and the thumb are, for example, from the controller. So you can have people point to things. You can have kind of pinch gestures, thumbs up, and that can also be reflected in the avatar when they look down at their hands. And so it's very immersive to run an app, look down, see hands, and they actually move like your hands should. So not only do we show the hands, we also give you vectors, what direction are they pointing in. You can do things like Unity UI raycasting. We already have provided example code for gaze-based raycasting in world space UIs. You can also do that now with the touch controllers easily. And tapping and also the current thumb pose. So there's a point for the thumb that can be useful for gunslinger games, for example, if you want to cock the gun. And also we provide a low-level way of serializing this data so that you can send it over network. We don't want to dictate your transport layer, so we just provide it as a buffer of bytes, and it's fairly well optimized, but you're free to re-encode it or transmit it however you want. So the SDK is designed so you can use the components together or independently. You can use just the hands and none of the networking or none of the head modeling. So there are a number of games that do that. You can use a full-blown avatar, or you can use a networked avatar or any combination thereof. So let's walk through how this actually fits into Unity. First, you're going to have to grab the Oculus utilities. Actually, there's only a dependency on OVR input within the Avatar SDK, but you do need to download the utilities for that. So you can bring it into your project, and then bring in the new Avatar SDK package, which we'll post in a couple of weeks on our download page. Can I ask, how many people here have already developed an app using the Oculus utilities? OK, a good number. So yeah, as you know, Unity has built-in VR support, which works very well. But then the utilities kind of supplement that with additional Oculus platform-specific functionality and then kind of some helper classes, such as a camera rig and things like that. We also have the OVR input class. And at touch launch, that'll be the most recommended way of getting the data out of touch. So that has support for both the 6-DoF poses, the capacitive touch as raw axes, the button states, and also it allows you to vibrate the controller. And the vibration functionality in there has been exposed in two different ways. There's the traditional set vibration, which you may be used to from like Xbox controller, Rumble. But there's also, since it's using a linear resonant actuator, you can also provide very detailed sound clips, like an LFE channel for a subwoofer, to guide exactly the kind of texture and feeling that comes out of the vibration unit. So that kind of low-level stuff is exposed through OVR input, and then the Avatar SDK layers on top of that. So once you've got those both imported, you can open up one of our samples, or you can just drag the prefab into your scene. And it's literally that easy. You can just hit play, and you'll be able to see your head and hands in VR. So our samples, there are 3 of them. There's a very simple one that just shows 2 avatars that are both driven by your immediate tracking data. So you can look across and see another avatar that's kind of pantomiming everything you're doing, your doppelganger or whatever. And that's called local avatar, I believe. OK, now see that there's a slight delay between the 2 avatars. This is the second sample, and it's allowing us to, what we're doing is serializing the tracking data to the binary format that I mentioned, and then kind of looping it back for the second avatar that's shown in the third-person view. You can then interpose your own network transport there and do whatever you want. We already have examples using the Oculus Platform SDK that work very well, but you can use UNet or whatever you want. And there's, again, a slight delay because we are actually buffering the tracking, which is coming in at 90 hertz. We found perceptually it's very important to actually retain like the full 90 hertz signal. So we don't downsample it. We try not to compress it too heavily. And all we do is coalesce it. So there is a bit of a latency to quality trade-off that you can make there. If you're willing to send network traffic every frame at 90 hertz, then you can have slightly lower latency. So within the integration, we have 4 folders. There's content, editor, samples, and scripts. So the content is just raw assets, and that includes all the models that you just saw. I don't know if you were looking, but there were some touch controllers in there as well. So the articulated controllers are using Unity's high-quality, physically based shader, the default shader, and we've set all the PBR properties to match the actual materials on the device. So it should be high fidelity and work properly with your light probes and everything. There's also a Unity plugin. So we're implementing this at the native level. The way the Avatar SDK works is that it has this representation that's stored in the platform, and then it kind of translates that into the game objects that Unity renders. So it's kind of just telling Unity what the renderers should look like, what the materials should be, and then setting, as I mentioned, the mechanism, skeleton, and skinning. Again, it's designed to be extensible. So you can go in and modify the way that Unity is receiving that data. And you can also, I'll get to this in a moment, you can mutate the way that the grips behave. You can throw in your own models. It's basically yours to control. The scripts folder contains everything that integrates with the native SDK via the platform and the native plugin. And then finally, the samples, which I've already been talking about. One thing that's worth mentioning is that below the avatars, you see this beam shooting up from the ground. Since we don't have actual tracking data for the lower torso, it would be a one-way ticket to the uncanny valley to try to fill in IK data for that. You'd look down, and the leg would be at a completely different angle. That we support seated and standing experiences. So what we found is that this kind of beam helps you occupy the space that your avatar is in, but it doesn't imply that we have more data than we actually do. But mechanism is pretty flexible, and if for some reason you want to do it another way, there's plenty of room to experiment. So yeah, another thing about the local avatar demo is that it's kind of the simple one that you can use to kind of inspect how the scene graph is set up. You can kind of see what the behavior is, populating the avatar from the low-level data. The light cone can be toggled as well. So if you didn't notice in the first sample, the light cone was not there, and in the second sample it was. The little avatar has one, and if you look down, you don't. So again, the remote loopback scene, that's the one that's writing out the byte buffer and playing it back, and that's a good boilerplate sample you can use if you're integrating. Probably if you're making a social app like Rooms, this is where you would start, and you can just kind of copy and paste this into your app. It's all kind of free to use. Don't feel hindered by if you have any questions about licensing, feel free to reach out to us. But we're expecting a lot of people to just kind of drag this into their apps. So here's some code that actually shows how you can initialize the Avatar SDK in your app. This was used for the remote loopback scene. All we do is initialize the platform, grab the user's ID, look up their avatar, and then update it. And the way that that's implemented is that avatars have a driver component. So the actual data that's supplied by the Avatar SDK comes in through the driver and gets applied to kind of the representation. In the first local avatar prefab that we looked at, the OVR avatar local driver is used. So that's one implementation of the avatar driver. And it just directly reads the data from the controllers. So that's being driven directly by the input on your local machine. The remote avatar prefab is the one you would have locally that's receiving data over the network, or in our case, from the binary stream, the binary buffer. And again, you can control the amount of latency that you want in your app. We went with a few frames here. And then there's a final demo, which is the controller scene. You can look at the articulated controllers. In some cases, you may just want articulated controllers, but we generally recommend against that because, again, you don't get the sense of hand presence. It's useful in situations such as like editor VR in some cases where you want to convey a specific functionality on the controller and guide the user to press certain buttons. But for the most part, it's more advisable to use the hands to represent the player. So here's the remote scene, or the controller's scene playing, and you can see the hands have been posed to accommodate the controllers by the Avatar SDK. The thumbstick articulates correctly, hitting one and the other button elicits the correct pose, and the triggers also move as expected. And as I mentioned, the capacitive sensors are what's controlling the hand pose. More about mutating the behavior. So by default, when you grip, the avatar's fingers kind of do this. You kind of have the second trigger controlling the bottom three fingers and the first trigger controlling your first finger. You can mutate that. So here we show the ability to do kind of like a Ronnie James Dio gesture. But yeah, you can modify the target pose. You can modify the pose that it lerps to for the grip, and then save it out as in a prefab, and it'll be used in the future. So I want to quickly touch on how you'll get your Unity experience to load the correct avatar for a given user. As I mentioned, you just initialize the platform SDK, look up the correct avatar, and then update it. And literally, with those 3 lines of code, here I'll back up. I can see my own avatar here in the editor. And I think I have great taste, by the way. This is one of many ways you can configure your avatar. I guess that's a video. OK. So that concludes the talk. Does anyone have questions about the Avatar SDK? OK. I'm just going to hand this off to the first person on the row, if you wouldn't mind passing it down. Check. Who was first? You in the pink shirt. Thanks. You mind passing that down?
So you mentioned that once you sort of log in and get the avatar data, you can sort of manipulate that as you'd like. So if I kind of get, like the specification of what someone's avatar should look like, can I then manipulate that to kind of like interpret my own style?
Yeah, right. The app can use the remote avatar driver to then, and you can either look up the remote person's Oculus ID and directly use their avatar, or you can have some arbitrary avatar, or you can take their avatar and mutate it. You're the one writing the C# code in your app, and you can mutate the way that Unity renders it.
Right, so it's not locked specifically to how Oculus wants to make it look, right?
No, that's correct.
OK, cool. Anybody else?
Behind you.
Thank you. Is this also possible in Gear VR or just the?
So Gear VR integration is planned. It's not going to be released at the same time as Touch Launch. I think you could expect it to be follow shortly thereafter, but I can't really state a release date yet.
Just to kind of go a little further on that, is there any additional platforms to be supported for the avatar system after Gear?
Well, we only have the Rift and Gear VR, and we're only targeting our headsets at this point. But Unity's mechanism system works well across other platforms as well. So it depends on what your use case is.
OK.
The plugin, I should mention, is not implemented for other platforms. So you'd have to be signed into the Oculus platform to actually get remote avatar data.
Can you use the Oculus platform code to purely do networking, or are you required to use something like Photon or Unet as a third party?
So the Avatar SDK itself doesn't implement the transport at all. We have a separate platform SDK that does that. And Unet works works very well. The focus of our platform SDK is more on social. So the focus of that is kind of rooms and joining parties, and then there's matchmaking, leaderboards. The VoIP that Avatar SDK uses is also implemented by the platform SDK. So you can basically use whatever transport you want. Obviously, as an Oculus employee, I'm going to recommend you use our platform SDK. That works well for peer-to-peer networking.
Cool. OK, so your platform SDK does have everything to do transform, locomotion, all that stuff.
Yes.
Cool.
OK, well, thank you.